In this video, we're going to be learning about density. The formal definition of density is mass per unit volume. Another way you can think of this is as how tightly packed stuff is. For example, in a pillow, the stuff is not that tightly packed. It's kind of spread out. So a pillow is not that dense. On the other hand, in a brick, the brick is very tightly packed, so a brick would be dense. Another formal definition is amount of matter per unit volume. And that makes sense because the word mass just means amount of matter. The formula for density is D equals m divided by v, where D is density, m is mass, and v is volume. And a good way to remember this is if you actually write it out. This part kind of looks like a broken heart. It's a little depressing, but density equals broken heart. The units for density are grams per centimeter cubed, grams per milliliter, or kilograms per liter. These two are actually the same because a centimeter cubed is the same as a milliliter. These two will be the ones we're mainly using in my class, but people also use kilograms per liter sometimes. Density can actually be used to identify substances because each substance has its own particular density. Density also does not change with the size of the sample. So here's an example of both these ideas. Aluminum will always have a density of 2.7 grams per centimeter cubed. So if you have a sample and you don't know what it's made of, and you measure the mass and you measure the volume, and you do mass divided by volume, and you come up with a number that is close to 2.7, you can assume that that object is made out of aluminum. Again, density does not change with the size of the sample, so if you have a block of aluminum and you cut it into smaller pieces, well, the volume is getting less as well as the mass, so each piece will still have a density of 2.7 grams per centimeter cubed. The ratio of mass to volume remains the same. Density also relates to states of matter, and as you should remember, the three states of matter are solid, liquid, and gas. There's also plasma, but we won't be talking about that until second semester. So, in a solid, the molecules or atoms are tightly packed together. In a gas, they are more spread out. So a solid is more dense, and a gas is less dense. This chart shows some densities of various materials. So dry air will always have a density of 1.293 times 10 to the negative third. If you recall, that's scientific notation, so that would be 0.001293. Brick will have a density of 1.9. Paper will have a density of around 0.7 to 1.15. So let's see if we can identify these substances by their density. So number one, if an object has a density of 0.24 grams per centimeter cubed, what is it made of? So let's go back to our chart. Remember that number, 0.24. We see the number 0.24 here. So here I see 0.22 to 0.26. So 0.24 would fall within that range. So this first object here must be made out of cork. Let's do number two. If an object has a density of 3.52 grams per centimeter cubed, what is it made of? So, which one is it here? Did you spot it? Alright, hold that answer in your mind and let's check your answer. should be carbon, diamond. Okay, number 3, if an object has a density of 2.7 grams per centimeter cubed, what is it made of? You should know this from earlier in the PowerPoint. .7 is aluminum. So let's see if we're right. Good. Number 4, what is the density of water? So water at 25 degrees is 0.99705. I'm actually going to round that up to 1. So 1 gram per centimeter cubed. One thing you may already know is that anything that has a density of less than 1 can float on water. Anything that has a density of more than 1 sinks. Let's do a couple density problems. So in this first problem, we have something with a mass of 3 grams, a volume of 0.155 centimeter cubed. So let's just plug this into our formula. Our 3 goes here, our 0.155 goes here. If you divide that, you should get 19.35. Now let's go back to our chart and see if we can't figure out what this substance is made out of. So remember that number, 19.35. So 19.35. It looks like it's going to be gold because gold is the closest to that. Now when you measure it, remember that you might not get the exactly right answer because humans make mistakes. And sure enough, it is gold. Okay. Now, second problem has a mass of 2 kilograms, volume of 103.5 centimeters cubed. Remember, we have to convert from the kilograms to grams. So I'm going to use dimensional analysis because we can always use more practice with that. So our first step is to write our conversion factor. So just remember the conversion factor is 1 kilogram equals 1,000 grams. The next step is to write down what we're converting on the left-hand side of our page. We're converting 2 kilograms. And we want to set up our fraction. And then we want to write down seq over half. So that means kilogram would go on the bottom, 1,000 grams would go on the top. Now we want to cancel out repeated units on the top and the bottom. Then we want to multiply everything on the top, divide by everything on the bottom, and we get 2,000 grams. So remember, when we plug things into the formula, we want 2,000 grams there. So D equals M over V. So we get 2,000 over 103.5, and that gives us 19.32 grams per centimeter cubed. Again, that is going to be gold. Last problem. This object has a mass of 15 grams, a volume of 1.91 centimeter cubed. So 15 goes here, 1.91 goes here. We have 15 divided by 1.91. And we get 7.85 grams per centimeter cubed. So let's go back to our table. Remember that number is 7.85. Any of these close to 7.85? Looks like it's going to be iron. Iron is the closest to that number. And sure enough, we have iron. So I hope you know more about density now.